In this lesson, we're going to examine algebraic expressions that involve exponents and how we can work on simplifying them. Our key idea is we want to use BEDMAS. That rules everything we do in math. So if we have things inside brackets, we should do that first. If we have exponents, two exponents, that second. Then we can apply our exponent rules, division, multiplication. That helps us simplify things. And addition, subtraction, though we often won't come across those things because we know when we have to deal with addition, subtraction, they have to be done separately. It's basically examples today, so no new rules. We're just going to work with the ones we learned about, our exponent rules. And so the first 5 from day 1, noting that we always want to express things with positive exponents. So we used a negative exponent rule. And we may come across some rational exponents like we did yesterday. So where do we start? BEDMAS says things in brackets first. Now, our brackets aren't meaningful in that there's nothing inside this bracket I can do. I can't simplify A and B because they're different bases. So the next thing I want to look at is, are there exponents, two exponents? And there are. So we have to apply the 2 to the B and the A. That'll give us A to the 2 and B to the negative 6. The next bracket will stay the same because there's no exponents outside of it. We can then apply our division multiplication rules. In this case, multiply. Bases are the same. The A's can add their exponents, and the B's can add their exponents. And remember, this one has a 1 on top of it. So negative 6 plus 1 will give us negative 5. I've simplified as far as I can, so now I deal with my negative exponents. I don't like the B being negative, so I bring it to the bottom and keep it same number, just opposite sign. And the A was fine where it was, so it stays on the top. And we're done. There's our simplified expression. And we'll try the next one. Again, look for brackets that are meaningful. This one's not because I can't simplify inside of it. So then I try my exponents. I see exponents to exponents on the bottom. So I'll leave the top alone and I'll apply the 6 to both the C and the D. So C to the 6, D to the 6. Division multiplication. I definitely see some division. Our dividing rule is when I subtract this way, when I divide, I can subtract my exponents. So negative 4 minus 6 is negative 10, and negative 5 minus 6 is negative 11. Notice I don't have a fraction anymore. My idea of dividing my exponents, my bases, eliminates the fraction. The fraction's gone because I created a single base. Notice my exponents are both negatives, so I got to create the fraction all over again and put the C on the bottom, the D on the top, and there's nothing left on the top except for the number 1. I'll try some more. I said these are just examples today. We're not doing anything new. We're just going to apply our examples. Okay, letter C. BEDMAS. Can I do anything inside the brackets? No. Do I have exponents? 2 exponents. Sure I do. I got to apply the 2 to the m and the n and the number. So I'm going to end up with 9 squared, m squared, and 10. Same thing for the next bracket, 2 squared, m6, and 2. Now we don't usually write the number 2 squared or 9 squared, so we'll fix that. We'll get 81 m squared and 10, and 4 m6 and 2. Now I want to simplify. Well, m's and n's can go together, obviously. So m to the 8, n to the 12. We're going to add our exponents. But the numbers are not the same bases, 81 and 4. So I go back to my idea of BEDMAS. What do I do when I have things in different brackets that aren't the same? Well, I multiply these things. That's what brackets really mean, right? So I'm going to multiply 81 times 4, get 324, m8, and 12. So the number part I had to deal with as numbers. The letter part I could deal with exponent rules. Make my life easier. And we'll try the next one, letter D. On the top, do I see brackets? I actually do this time. I see stuff inside brackets that have to be done before I do the exponents. So what can I do inside that bracket? I can apply the negative 3 to everything inside it. What will that get me? 3 to the negative 3, g to the negative 6, and h to the negative 3. And all that squared. Okay, so I'm following my bedmass rules. On the top, what do I have to do next? Exponent to exponent. So I need to apply the 2 to everything inside that bracket. Notice just the top, because the bottom is not inside the bracket. So we're going to double all these things. Negative 12 and h negative 6. Okay, G3H negative 1. So I've simplified a little bit. I did my B and my E. Now I've got some division. So I can get 3 to the negative 6. G, we're going to subtract. Negative 12 minus 3 is negative 15. And negative 6 minus negative 1 is negative 5. I've gotten to the end, so I got to deal with all my negative exponents. So, enough for the 1 on the top, 3 to the positive 6, 3 to the positive 15, h to the positive 5. We don't usually write 3 to the 6. We figure out the actual number. I believe it's 729, G15, H5, and don't forget, we got that 1 on top. Okay, so we're following bedmass. Don't deal with negatives to the end if you can avoid them. And make sure you deal with the numbers at the end also. Okay, let's try the next one. Now the next one looks kind of odd. It's written in radical form, or we know we can fix that. Let's rewrite this in a form that involves exponents instead of radicals. So the fifth root of x means I need the 5 on the bottom, but I also have it to the power of 8, so the 8 goes on the top. Same thing on the bottom one. I see a square root. I know it means a half, but actually this time we want to cube it, so 3 halves to the 3. What should we do first? Bedmass says we should do the stuff inside the brackets first. My bases are the same, so I can subtract my exponents. We're going to think of this as 8 fifths minus 3 halves. You may want to use your fraction button in your calculator for that one. Okay, what do we get? 8 fifths minus 3 halves comes out to 1/10. So I did this stuff inside the brackets first. And I can do my power to a power, which means I get 3 times 1 is 3 tenths. You can leave it that form if you want to, or because it was written in radical form, we could put it back into radical form. Either that format, or if you prefer, because that's how we calculate it usually, this format. They both mean the same thing. Okay, try the next one. I have bedmass. Is there anything I can do inside the brackets? Not really. So I follow my E, exponents. I have to apply the 1/3 to each of these things. Similarity on the bottom, the 1/2 to each thing. So 27 to the 1/3, a to the negative 1, b to the 4. Multiplying by 1/3 is the same as dividing by 3, right? Same thing on the bottom, 16 to the 1/2, a to the negative 4, b to the 6. Okay, what can I do next? Well, 27 to the 1/3 is actually a number. It's number 3. 16 to the 1/2 is also a number. It's the number 4. So I'm going to kind of separate this question into 2 parts. The number part here became 3/4. And the letter part, I can deal with my exponent rules. I can do a to the negative 1 divided by a to the negative 4, subtract my exponents, and I get a3. Same thing for the next part, b negative 2. Now, there is a fraction here, 3/4, or if you want to, you can think of the a and the b being on the top. When we subtract things, they always end up on the top. Or think of there being no fraction, right? That's the same thing. I got to deal with my negative exponents. So what things do I not like? I don't like those b's. So I'm going to move them to the bottom. And so we got to be kind of comfortable with the fraction idea. Whenever we subtract exponents, they end up on the top. Okay, I think of there being a minus, or sorry, just a 1 on the bottom. Okay, we're going to try another one. I want to simplify and then evaluate. And this time I've been given values for my number. Now, I totally could plug them in right off the bat, but that means I end up dealing with big numbers, lots of numbers. I'd rather simplify first to make my life easier before I ever have to evaluate. So, bedmass, no brackets, no exponents to exponents. I can go to my division and multiplication rules. If I subtract, things end up on the top. There's a 1 here. I get a to the negative 4, and I get b to the 1. I got to fix. A has to go to the bottom, B stays where it is. That's simplified. Now we can evaluate. Every time I see a B, I'm going to replace it with a -1, A with a 2, and I can calculate that really quickly. Rather than having to calculate with a bunch of numbers, I can do it at the end with not very many. All right, same idea, a more challenging equation. Can we simplify this and then evaluate? So bed mass, brackets, are those brackets meaningful? Not really. I can't do anything inside them. Do I have any powers to powers? No. So division multiplication rule. On the top, my bases are the same, so I can add my exponents. If I add these two things together, we'll end up with 5n, and positive 1 and negative 1 will cancel each other out. On the bottom, stay the same. I've got division now, so I can subtract my exponents. 5n minus 2n is 3n, and think of it as 0. 0 minus -5 is plus 5. It's simplified. Now we can evaluate. Okay. X is supposed to be the number -3, so I'm going to put it in brackets. 3n, n is 2, plus 5. Will give us -3 to the power of 11. Make sure it's in brackets. And then now I can calculate this, which will be a big number. But it's much easier doing it at the end than doing it all the way through with all those big numbers. I believe you get -177, 147. Okay? That's it. We want to work on things. So it's not necessarily a hard thing, but there's a lot of parts and pieces to keep track of when we do exponents. In particular, let's go back for a second here. The most common mistakes that I always see are people forgetting to apply their exponent to numbers. They remember to do the 1/3 of the A and the B, but they forget numbers. So make sure you apply everything, exponents to everything that end up in brackets. Okay? Homework? And that's the end of our algebra part of the exponents. We're going to start looking at the graphs next.